Good evening. Oh, thank you. Welcome to Imperial College. My name's Deborah Humphreys. I do stuff here at the college. You don't really need to know that. But I'm just here to give you a huge welcome. And then we've got people from all over the place. Have we got anybody here from Newham? Newham? Yeah, Newham, yeah. Anybody from Harlow? Students from Harlow? No, obviously not here yet then, okay. Anybody from Horsham? Yay, Horsham, hello. Okay, and I think there should be some people from Hammersmith. Yay, thank you, Hammersmith. Anybody here from Hampshire? I'm from Hampshire too, welcome. So, welcome to Imperial College, to our annual Christmas lecture. I am absolutely delighted to welcome you and to thank the Institute of Engineering Technology and the Worshipful Company of Engineers for sponsoring this. As you can see, there's lots of kit and things involved, so it's fantastic that they've supported this lecture. Now, this evening's going to be amazing because Dr. Simon Foster is really quite astonishing. And I'm really delighted to welcome him. He's a former science teacher, and he now does outreach here in our Department of Physics. So when you're thinking about coming to do physics, you'll encounter Simon much more. I think you're going to be amazed. I think you're going to find his lecture quite astonishing, and there'll definitely be lots of bangs and whizzes, smell and smoke. So hang on, hold on in there. So I'm going to, without further ado, over to Simon.
Hi guys, hopefully you can all hear me. Is my mic, is it all working? It seems to be saying, is anyone here from Edmonton? Just me then, right, okay, so I'm going to cast a very lonely person up here. Right, ever since I was a child, basically I was obsessed with rockets, okay? I was obsessed with images like this. I wanted to be an astronaut, never quite came off. You've heard me coughing and wheezing because I've got asthma, and I've been blowing stuff up for the past couple of days practicing for this. It never quite came off for me, but I was really lucky. I went to university and I studied space science, so I actually became a rocket scientist. And after that, I went and studied solar physics. I worked here at Imperial College for a while as well. And basically, all the amazing stuff we do here is basically, lots of it is based on using rockets and satellite technology. And so basically, to get stuff up into space, to use satellites, we need rockets. And hopefully, by the end of today, I should have hopefully got across all you need to know to make your own rockets, which probably your parents and teachers don't want you to know, but hopefully don't try some of this at home, or do, basically, I don't know. You're not my responsibility. I shouldn't really say that. But anyway, right, before we get started, I'm going to ask you lot a question. So, I wonder, I'm going to ask you to put your hands up in a second, if you could tell me when you think human beings first tried to launch rockets, well, with humans actually, rockets with humans, into the atmosphere, into space. Now, was it, seeing it's Christmassy, around 2,000 years ago when baby Jesus was born? Since about 230 years ago, this is Montgolfier brothers, and they launched the first hot air balloon there, or about 60 years ago when Yuri Gagarin went up. So, can I have hands up for A? Got about 4 or 5. Right, hands up for B. Oh, that's about nearly half. And hands up for C. That's, well, the other, well, that isn't quite the other half, so that's quite worrying. Some of you haven't voted. But anyway, quite strangely, it was over 2,000 years ago that human beings first tried to launch themselves into space using rockets, okay? And for the first part, I'm actually going to need a volunteer. So, it's quite worrying. Too many hands went up there. I'm trying to see. I'll take that young lady at the end there in the red, okay? Right, so stay there. What I need you to do is, can you please put on a pair of the gloves, the mask, and the glasses for me, please? Okay, down there? That should be okay. Right, once you're doing that, Basically, why we need all that is because about 2,000 years ago, the ancient Chinese discovered gunpowder, okay? And they said in their kind of encyclopedias at the time, in their book of texts, this is a photocopy from something called the I Ching, whatever you do, don't mix 3 chemicals together because you might get a fire, basically, or an explosion. Now, after a while, obviously, people thought this is quite a good idea to mix chemicals together to get fires or explosions. And actually, what we're going to do now is look at how to make gunpowder, okay? So, and by the way, the ingredients for this are ridiculously easy to get hold of, okay? Actually, most of the stuff you can get from the pound shop, which is quite worrying. So, starting off, and you're going to help me with this, okay, which is why I need you. So, can you come over here, please? Can you put a mask on as well? Well, they're just in there. Actually, don't worry about that. The chances of anything going wrong are minimal. So, I've just realized the one thing I forgot was my pestle. No, a spatula, because I'm not a chemist, I'm a physicist. So, I've got it in here. By the way, if any of you see me on the tube with this bag, don't sit next to me. Okay, I'm just really happy the police don't know any chemistry. It's really quite lucky the amount of times I've been stopped. Right, so what I need you to do, if you can, is take 1 spoonful of carbon, the black powder, and put it into there. So this is, actually, are they not fitting properly? I'll get you some other ones. Try these. These might work a bit better. Ah, there you go. So I don't want to poke you in the eye. Right, just leave them down there, that's brilliant. So, if you can take the top off the black powder there, it's carbon. So this is just the same stuff you get in a barbecue. By the way, the best stuff for this is the stuff you find in the pound shop disposable barbecues. Okay, their carbon works unbelievably in gunpowder. So, can you take 1 spatula's worth, please, and stick it in there? It's quite a lot, but that's not a problem. Right, can you please take this and smash it up, grind it up, please. Okay, so obviously when charcoal in your barbecue reacts with oxygen, it gives off heat, but it does that over a very long time. But what you want in gunpowder is for it to be given off very, very rapidly, okay? So the charcoal on its own isn't going to do much good. How's that coming along? Let's have a look. Well, that's not bad. Let me just get some lumps out because in a minute it gets dangerous. Right, now, what we need, this is the magic ingredient, okay? This is called potassium nitrate or saltpeter, okay? Now, have you ever had salt beef, fish, bacon, anything like that? The preservative that's used on that is actually the main ingredient in gunpowder. It's unbelievable. So I need 3 spoonfuls of that into the bowl there for me, okay? Roughly the same size as the last one. Are you going for the big rock? Shall I help you? Right. Let's get this out. Actually, let's use the big rock. We'll say that's 2. And then get another one out for me. So I got this from our chemistry stores. And what's quite alarming is they said, why do you need 1.5 kilos of potassium nitrate? So I said to them, I thought I'd be honest. I said, I need it because I want to make gunpowder with children. Because I thought you've got always, honesty isn't always the best policy, but I try. So they said, and they just went, fine. I thought, why have you asked me that question? That's so bizarre. And it turns out they're more worried about people illegally making their own salt beef than they are about people using it for explosives, which I find absolutely amazing. Now, what I need you to do is grind that together for me. I know I'm doing it. I'm just trying to get rid of the lumps. So can you mix that up for me? Go round and grind it up. Now, this is called an oxidizer. So what it does is it rapidly supplies oxygen to the charcoal in there, the carbon, and hopefully we'll get a nice big flash. So how's that coming along? Not too bad. Can I just grind it up a bit? I'm a bit worried about the lumps. That's all. I'd rather it blows off in my face, because technically I'm not really worth insuring, but you are. So that's looking nice there. Oh, that's good. Right, and finally, can you add some of this sulfur? So this is just sulfur. It's what gives you, the rotten egg smell when eggs have gone off? Eggs naturally contain sulfur. The shell is slightly porous. That means air can get in. It reacts with it, and it gives you that, whoa. All right, that'll do. Go on. Why not? So I need you to grind that all together for me now, okay? Really slow. Yeah, maybe don't bang it. Okay, not now, just go around nice and slowly, okay? So get that all mixed up together and go and get some, actually I shouldn't really leave you alone with it, but oh well. In for a penny. Now, what we've just done there is completely illegal. It's actually illegal to make gunpowder these days, so obviously there was that thing with Guy Fawkes, they weren't too pleased after that. So let's see how this goes. Okay, if we can just have the video, oh God, you've made a ton. Right, so if we can just have the video back up. Oh, actually, keep this here. Right, keep your fingers crossed. I don't know which way you want them crossed, either for this to go up really well or not. But we've got a nice lump of gunpowder there. Now, this usually works. You might want to get back. Actually, I've realized I better be wearing these. So, are you ready? The what? Oh, that. Sorry, are we up there? Sorry, I thought we were on the other camera. Sorry. Right. I'll bet. Oh, I've got this as well, just in case. Should be all right, but there is a hole in it. One went a little bit too vigorous. Right. Keep your fingers crossed. Whoa. I'm hoping it'll go out. The mat shouldn't catch fire, which it has. Yeah, that's made it better. Right, brilliant. So we successfully made some gunpowder. Brilliant. If you can leave your glasses and your gloves there. God. Right, by the way, the smoke alarms are turned off. I don't know if that's kind of nice for you or not, but can we give a round of applause, please, to the first volunteer? So, making gunpowder is ridiculously easy, okay? You can actually, as I say, make it with stuff you've got lying around the home. You probably shouldn't, but you can. And basically, it can do one of two things. Now, this is what I was worried it would do. Quite glad it didn't do that. Okay, it's quite fun when that does happen, though, I should point out. Instead, we wanted it to do what it did. We wanted to have a long, slow burn like this, so basically it can fire rockets up. And what you've got here is basically Newton's third law of motion in action. Who here has heard of Sir Isaac Newton, one of Britain's best or most famous scientists, okay? Brilliant, okay? Now, he had 3 laws of motion. I'm trying to teach you some physics here, accidentally or by chance. So, basically, when you have an action, you have an equal and opposite reaction. What that means is if you have a push in one direction, you have a push in the opposite direction. Who's been ice skating recently, or ever? Who's actually any good at it? Okay. It's at a broken wrist, because I've had mine done, okay? Because basically, I end up holding onto the side an awful lot like this, and my feet shoot around. And if I push in that direction, what direction are my feet going to shoot? That direction, equal and opposite, and the same is true for rockets. You have all this lovely exhaust gas coming out the bottom, and your rocket will fly up into the air. Now, about 2,000 years ago, a famous Chinese scientist had the diamond bullet idea, okay, of placing 36 gunpowder rockets around the bottom of a chair and using it to launch himself into space, okay? Now, according to the records, he disappeared in a puff of smoke, never to be seen again. Now, according to his friends who are standing on looking there, this was a successful launch. Now, I'm not so convinced because, quite frankly, if it's so successful, everyone would have started doing it. But there are some people who said it was successful. Now, just to check, and just show you, who's heard of Mythbusters? I've kind of ripped this off from them. They basically recreated it. So here you've got the gunpowder rockets at the bottom. This is a crash test dummy, by the way. And there's a kite on top, because he wasn't stupid. Obviously, once he was up there, he needed to float back down to Earth, okay? So, we're about to see what would have probably happened to poor old One Who. Now, there was a puff of smoke, And he probably wasn't ever seen again, but I don't think it was that successful, okay? So I'm going to shamefully skip about 2,000 years of history, because after this, people were kind of, not too sure about rockets, really. They were like, not sure about that. Used them for fireworks and other things, but no one really tried to go big. Until this fella, and he's called Werner von Braun. Now, he's basically known as the father of NASA. But before that, he worked with another group that began with N, and that was Nazi Germany. And he basically dreamed of launching rockets to the moon. Unfortunately, quite a lot of them hit London, basically. And this is the V2 here, okay? And this was the first big rocket that was ever developed, okay? They also developed the V1. It was called the Doodlebug, which you can see here, and it fires off. And it's got this wonderful pulse jet here. We can see it and hear it, hopefully. Oh, there's one going wrong, thankfully. This is the sound. Okay, this used to fly over London during World War II, and when the engine went out, everyone used to get scared and run around. Now, bizarrely, these rockets are fueled by pure alcohol. So the stuff your parents and your teachers are going to be drinking around now, possibly after this talk, is actually rocket fuel. I kid you not, okay? So you can use alcohol. So there's certain rums and whiskies are very good for this experiment, kids. If you want to get home, you can try this out, okay? So what I've got here is a dash of pure alcohol inside a bottle. I'm going to shake it up, and hopefully we're going to build a rocket engine. Now, this should be okay. So I'm going to try and mix it with the air inside. I've got it there. And where are my matches? They're here. So fingers crossed this is going to work. God, someone's already choking, which isn't a good sign. So this is a very primitive rocket engine which you can build at home very easily. Woo. You can see it pulsing there. Right, I put that over. Very safety there, plastic cup on top. That's always great, isn't it? But that went fairly well, I think we'll agree. But you can do better than that. Actually, I should point out, because this is the one where I get really scared now. Because by altering ever so slightly the nozzle on it, where the gas comes out, can you see on there? By altering that ever so slightly, you can get far more thrust, which hopefully we're about to find out. So I'm going to shake this up nicely. It's been under the hot lights, so we've got a good mixture of gases in here. I did burn my thumb quite badly doing this yesterday, which is why I'm going to use the meter ruler. That should fill you with confidence. Because some of you are probably going to be a lot closer than me. So, let's hope. Oh, it's gone out. It's just building the tension, don't worry. So, hopefully this will work. That went fairly well. I'll be honest, that went a bit too well. And I'm very glad I used this instead. But you can see the same amount of fuel with a tiny, tiny, tiny hole instead of a big one produced so much more thrust. So people were getting the ideas around rockets. Now, I've got one here. Hopefully you can see it over here on the string. So this is just basically a normal bottle, plastic bottle, filled with a tiny amount of alcohol, which I'm going to shake up to hopefully mix with the air. Now, this worked perfectly yesterday. So I will do it with that caveat. It did work very well yesterday. I haven't tried it in here yet, so let's see how it goes. So I've got another nozzle with a tiny hole in it, and I'm praying that this will work. Right. Right, let's give this a try. So this can be quite hit or miss, which isn't very good to say in this kind of experiment, but let's see what happens. I didn't go too bad. Has that gone out? I'm quite happy that happened. But so that was a tiny, tiny amount. Can we go back to the slides, please? That was a tiny amount of alcohol in there, which is shook up, worked beautifully, okay? So that was what got the first rockets up into the sky. But unfortunately, it didn't quite work out because basically, after World War II, there was a period called the Cold War. Have you all studied this in history or have you heard about it? It was basically the Soviet Union, Russia, versus America, basically. Well, more or less. They didn't like each other very much. They both had nuclear weapons, but they realized if they used their nuclear weapons, both would destroy each other. It was called MAD, Mutually Assured Destruction. So what they decided to do was use science to try and beat each other, to show how great they were. And one of the things they did was come up with something called the space race. Okay, and they wanted to get satellites and people up into space to show how great they were. Now, down here, we've got the V2 rocket, the one we just saw. Okay, well, not literally, but we've got it down here. This is 11 meters in height. If you go into the Science Museum, you could see it. The rockets that took human beings to the moon is shown here, the Saturn V. This is 110 meters. Okay, it's bigger than Big Ben. What's amazing about it is incredibly thin. So you know it's a Coke can. When it's full up, it feels really solid. But when it's empty, there's hardly anything in it. You can crush it really easy. If you go to the Leicester Space Center, they've got rockets up there, and you can feel them. And the cylinder, there's hardly anything there. You can push into it really easily. Now, the problem with the Saturn V is alcohol simply wasn't powerful enough, believe it or not, to get it up into space. They needed bigger and better fuels, okay? Now, one of the fuels you can use is this. Actually, have you got any science teachers here tonight? You can try this out at school if you want. Maybe you might not want to, but this is solid fuel. But this is potassium chlorate and sugar, and I believe it's using sulfuric acid just to get the reaction going, okay? So this is a rocket fuel that was tried. Oh, God. Maybe it doesn't want to try. Some fuels are a bit too powerful to use, okay? We have to be really careful with them, okay? You can try it out at school. Probably you don't want to, but you can try it out. So, actually, what's amazing is the Russians had a fuel that produced nitric acid as its waste product. Okay, this is really bad. It burns your skin. So as the rocket would fly over, nitric acid would pour out onto the countryside below, okay? Not particularly good. Now, actually, I better use a volunteer for this. I'll tell you what, we'll use that chap there. I saw him put his hand up. You won't be saying that in a minute, trust me. Right. Can you please put this on? I did warn you, afterwards, I suppose. But Lorna, it's right if you get the, actually, do you want to come forward down? If you come down the front here, just stand in front of the lectern. Right. So, basically, weirdly, you can use water as fuel. Now, I know that sounds really odd, but water, have you heard of H2O? Made of 2 parts hydrogen, H2, and 1 part oxygen, O, okay? So the hydrogen is slightly positively charged, and the oxygen is slightly negatively charged, okay? Now, the great thing about hydrogen and oxygen, when it's together as water, you've got it here, it's basically very inert, it won't do anything. It puts fire out, okay? But actually, when you split it apart, hydrogen is very, very combustible, okay? And actually, now I gave some of you, or some of you have got batteries and water. Can you drop, I know it sounds odd, the battery into the water? Okay, and then pass it. Don't worry, it won't go bang, hopefully. Just drop it in. Now, in a couple of seconds, hopefully you should see at the negative terminal, that's the fatter terminal. If you pass it around afterwards as well, you might start seeing bubbles, hopefully. That's hydrogen gas being made. You've got rocket fuel being made there in your palm really easily, okay? So you can use electricity to pull water apart and actually make rocket fuel. Now, the great thing about hydrogen is that when it recombines with oxygen, all you get back is water again, and you get energy out, lots and lots of energy. As we can see there, it's really easy to make, really easy to make. Doesn't really produce any pollution because all you're doing is making water. And you get a very powerful explosion. And what you're about to do is, well, we'll see, actually. So, You've all seen lots of times kind of at political parties and stuff like that. This is from a kind of conference in Armenia, Yerevan, and these are balloons filled with, well, a lighter-than-air gas, okay? So, what we're going to try out is, you're me, we're going to play a game, and it's called hydrogen or helium. So, we have one balloon here that's filled with helium and one balloon filled with hydrogen. And you may think I've done the colours there to confuse you. I don't know. And what you've got to do is guess which one is filled with hydrogen or helium. I've got the music up to just dull any screams. But which one? I'm sure it'd be all right. 50% of the time it's fine. And last time went really badly, so the odds are in your favour. So, which one are you going to go for? Which one do you think has got the hydrogen in? Pick one. You got 50, that one. Right, let's try it out. You're coming down with me. So, you might well get your hands off that. So, what I need you to do, actually you're going to be a lot closer than him. I didn't think this through. That happens. Sure, it'll be fine. Right, what I need you to do is ignite that for me, please. Oh, let's get it alight again, mind out. He's building the tension, he's a pro. Try that. Try hands over ears, guys. So that was helium. Okay, so light and air gas. Well done. Well, you survived, which is always good, isn't it? So, by a process of elimination, this should be hydrogen. I'll try this one. Actually, do you guys want to get back a bit? We might want to clear a space, actually. I got this from the chemistry lab, and it's very pure. So I'm not sure. I usually make it in a really shonky way. So let's see, hopefully. Let's keep our fingers crossed while we've got them. You're laughing now. We're about to find out. So, well done. I should have got you to do that. So I was a bit worried because I suddenly thought I was going to get him to do it, and then I suddenly thought I haven't tested this out, and this is going to be one of them awful things on a health and safety form or course where some idiot let a child blow a balloon full of hydrogen up. But anyway, it kind of went well. So that is rocket fuel, tiny amount. You can actually, again, make this with stuff out of a pound shop. I won't ask, or won't tell you actually, but ask your chemistry teacher or be good in chemistry, listen up, and you'll work it out really quickly. It'll probably come up in about year 7 or 8. So you can make hydrogen really easy, rocket fuel. So basically, let's go back to our political rally here quickly. So we've got it here. So we've got all these balloons full of hydrogen. Even children can play my favorite game of hydrogen or helium, okay? So, got it here. So, obviously, what are all these balloons filled with? Helium. Should be filled with helium. But, unfortunately, on this day, they've filled them with hydrogen. Amazingly, everyone was perfectly safe in that. Even her hair, eventually. But, she was okay, trust me. Everyone was fine, amazingly, okay? But that just goes, I've had that happen to me. I asked for a balloon full of helium and someone gave me a balloon full of hydrogen. It was not fun, I can tell you that. But luckily, went off, everyone was okay. So that's rocket fuel. That was next to nothing, okay? Now, this is the rocket engines on the space shuttle, okay? It's just been decommissioned. Each one was about the size of this table, okay, in diameter, if you think about that. Each one of these, every second, is burning a ton of hydrogen, Okay, so that's the weight of a car of hydrogen is burning in these engines, and there's 3 of them there every second. You can imagine the power. That was a tiny, tiny, tiny amount of hydrogen. The amount of power coming out of this is ridiculous. Okay, but as we know, or as I'm about to tell you, it was the Russians who first got into space, actually. They launched a satellite called Sputnik, okay? And this is the sound, actually, I'll tell you. So, it was transmitting a radio signal. It was about the size of a football, okay? And it was transmitting a radio signal. And you could actually tune your radio in to listen to it. Now, for many Americans, this was the scariest sound they'd ever heard when they tuned in. It doesn't sound that scary, does it? But they had no idea what it meant. Was it a secret signal to try and control their minds? Okay, it was actually just meant beep, beep, beep. That's all it actually meant. The big problem was that at the time there were remote control garage doors, and they were just coming to be really big in America at the time. And Sputnik's flight path was over Florida. Now, accidentally, Sputnik was transmitting on the same frequency that most of these garage doors worked on. So every time Sputnik would fly over, all these garage doors would start opening and closing, like a kind of really terrible episode of Doctor Who from the 70s, okay, where garages start eating people. This really freaked them out, okay? Their garage doors were being controlled. What else could the Russians do? So they needed to get a human being up into space, okay? This became a really big priority. So, there's a problem with getting human beings up into space, though, okay? Because if you lose a satellite, or satellites and robots are a lot more kind of, well, we're quite squishy. So there's a problem with that. You're probably, who's going home on the tube or the bus tonight? When you're on it and you feel, it's the same with a car, and you feel it accelerate, you'll feel yourself pulled in the opposite direction. Okay, it's actually G-force. When you go around a corner, if the car's turning that way, you'll feel your body pulled out in the opposite direction. You're actually feeling weight added to your body. If you go up and down in a lift, you can feel it, okay? Now, going up into space is really hard for the human body, and they test pilots out, or astronauts in one of these. This is called a centrifuge. So people are inside this being spun around, okay? What's really good is they actually have the video, and you can see people inside it, okay? So up here is the amount times more than Earth's gravity they're feeling. So the moment you're feeling 1 G, 10 Gs will make you feel 10 times higher. We're all very squidgy, so that's getting pulled back. The other problem, you can see them taking very deep gulps. It's because your lungs are being squashed back. It's very hard to breathe, so they're having to take very short, deep breaths. There. Now look at this. Up in the top, 6 Gs. In the first rockets, you needed to be going about 8 or 9 Gs at least. He's enjoying it. So's he.
Right.
See? And they're holding here called a dead man's stick. When you pass out, because your heart has to pump blood to your brain, all the blood gets pulled down into your feet, and your heart has to pump really hard, so you go out after a while. So you just pass out, you let go, or this can happen.
Stay tight, stay tight, stay tight.
I know I look really sick. I found this hysterical when I first saw it. But
Coming back around?
this is called G-lock, gravity-induced loss of consciousness. Now, this happened on this chap at about 4 Gs. You do not want this happening to your astronauts. You don't want them passing out. He is all right, trust me. Well, you know. Oh, there he is. He's back. He's smiling. They're all kind of there. The other problem you've got with this is obviously you've got a big sack of liquid in your stomach. And that's got to get pulled around. You know when you go on a roller coaster, you feel awful, don't you? You kind of squashes that about, throws that about. This chap isn't looking too good there.
You feeling nauseated?
And that's the other problem.
I'm going to vomit.
You can see it there. So, you got a big problem. There they go. All the women were fine though, amazingly, actually. But there's a big problem because you've got to have a really strong heart to pump blood up to your brain. You've got to have really strong lungs, and you've basically got to have a really strong stomach because you don't want to be in a rocket with someone who's just thrown up, do you? So basically, you've got to make sure they're quite solid. Now, 1961, the Russians launched the first human beings into space, or the first human. He was called Yuri Gagarin, okay? And basically, Yuri was great. He's a very intelligent guy. He had a very strong heart, very strong stomach. He was also very small because they actually built the capsule and forgot what they were meant to put in it. that is a human being. So they had to basically crush him in it, and he was only about 5'2". He was really quite small. But Yuri got up there. He went around the Earth a couple of times. Obviously, this really scared the Americans. Okay, we actually scared everyone in the West. Because basically, the Russians or the Soviets had now got the first satellite into space, the first human being into space. We were starting to look really bad. So they decided that we would go to the moon, okay? But there's problems with going to the moon. Now, yeah, haven't you learnt your lessons? Seriously. I'll try and pick one from the back. Says, someone in a check shirt looks like they're about to explode. Yes. Sorry. Nash looks very dejected. So, come on down. This is the end of your life. Right, brilliant. So, can we have you up down here, please? So, the problem we've got in space is that space is a vacuum, and things start to behave very oddly in a vacuum. Now, hopefully, we've got vacuum chamber here. What I need you to do is, can you try and pump all the air out, hopefully we can see this, from inside. Okay, actually I'm going to get rid of this because we don't want accidents. Yeah. So what I need you to do is put that on top and just start pumping the air out for me, okay? So, problem with space being a vacuum is that things behave really strangely in there. Can you hopefully start to see this inflating? Now, if you go into space without a spacesuit or a very good suit, your lungs are just like this, okay? So they're two big sacs of air, and can you see what's going to happen? They start getting bigger and bigger. Can you see it on here? So hopefully, can you see that going? Right, let me try and, what I'll do is I'll shrink it back down. So hopefully you can see that. Now this is a bit rubbish, and I couldn't be bothered to do it, so I'm going to cheat and use my vacuum chamber I've got here. So this is actually a big vacuum, and you're going to help me with this. You won't be saying that in a minute. Can you put those on, please? Now, I've got to remember how to work this. It's really bad. There's a way that works and a way that doesn't. We'll find out. So, I'm going to get some water. Hopefully you can all see inside. And where's my water? It's down here. That's all right. So I'm going to put this in. So, oh, that's way too hot. Let me get some cold. So hopefully we've got some cold water here. So, you have a lot of water inside you. It's called blood. Yeah, that's nice and cold. Finger in there. It's cold-ish. Right, brilliant. So, we are now going to see what happens to blood in a vacuum. Whoa, maybe not. So, your lungs will pop. That's not the biggest problem, believe it or not. So hopefully, can you see that all? Right. A lot of coughing, that's great. So, I'm going to turn this on. What this is going to do, actually, did I give you glasses? Yeah. Oh, you've got yours as well, brilliant. I always forget those. We can see it hopefully starting to pump up. And what this is going to do is take the air out from inside this chamber, okay? So, hopefully, and I don't know if, can you see on here? I don't know if I can bring this forward. Hopefully, can you see it should say 1,000 on here? That's atmospheric pressure. So at the moment, there's 1,000 million. It won't go pop unless something goes really bad. And in which case, you'll be fine. It'd be me and us three. We'll be in trouble. So hopefully, that's going down. Brilliant. Right, I'm going to now try and take the air out from inside of here. So is this dropping down? Brilliant. Right, it's working. It's all right. Earlier. Now, hopefully, this is actually starting to become like space. I'm removing all the air from inside, and hopefully we should start seeing after a while what will happen to your blood. Now, is this going down? Yeah, it is decreasing. Now, it takes a few seconds to get going. Actually, I just started to see it there. Actually, can you start seeing steam begin off? Or is that just me? I'm trying to pretend it's actually working here, actually. So hopefully, oh God, I've got to stop saying this. But if you were to go into space, have you seen the big suits they're wearing? That basically pressurizes them. There was a guy, did you hear about Felix Baumgartner? he went up into space. A guy did that in the 1960s in America called Joe Kittinger. Okay? He went up in a helium balloon, went up 3 times. On one of the times, his glove tore, and his arms started to swell up. It swelled up to twice its normal size. Now, instead of doing the sensible thing of just jumping off and getting back down quicker, he put his other hand over the suit to hold it in place and went all the way to the top, okay? Now, what you've got to be really careful, and he would have been in a lot of pain. Now, here we go. Hopefully, this is getting down to atmospheric. This is getting down to a vacuum. Can we see anything happening yet? I'm starting to get nervous now. Can you say anything? Just nod. Yeah, brilliant. You'll go far in science. Ah, it is starting to. Can you see? Hopefully you can see it's starting to boil. Everyone say yes. Pardon?
How did you know?
Nose, well, they're not going to become rocket scientists. Oh, God. Right, I'm going to leave that going because I'm worried. So let's keep that going. Congratulations. You were meant to do something else, but actually, I'm really frustrated. That was meant to... Well, at least it was one that didn't explode in my face that didn't work. That's always a benefit. So I'll keep that going, and hopefully it'll get going after a while. What's it saying on here? Yeah, it should be working. Actually, it's going now. Oh, thank God. Right, after I nearly wrote it off. Right, it was teasing me. The swine. There! So it's starting to boil. So this would have been like your blood in space, basically. It would actually boil. So, okay, when people say, oh, you're making my blood boil, if your parents or your teacher said it, you can actually turn around and say, well, you're not in space. But this is actually what would happen, okay? So this is a real problem. Your lungs wouldn't burst. Well, they would, but that wouldn't be the problem. The problem in space, what you would die of, one of the things, is your blood literally boiling, okay? And it wouldn't take that long, trust me. It would actually go pretty quickly. Now, there's a way, hopefully, of doing this safely. So, is that boiling away still? So, hopefully, and then we'll evacuate it. Still going away. Turn that off. And then, hopefully, we should see lots of steam. So the water that was in there as a gas has become a liquid again. Because when it's repressurized, it can't be a gas anymore. There's not enough air pushing down on it. And hopefully, just to prove no jiggery pokery. Oh, hey, it worked. Can you stick your finger in that? Just prove.
Same temperature.
Brilliant. So actually, that was about your blood temperature. Your blood would actually boil in space. So that's a big problem, ladies and gentlemen. Round of applause, please. Oh, just throw, there, perfectly. So, now that's not the only problem you've got going into space. The other problem you've got is the cold. Okay, space gets very, very cold. Okay. Could get down to about minus 200 degrees, minus 270 degrees. What I've got here, I've gone from very hot to very cold. I've got a substance called liquid nitrogen. Have any of you heard of that? Okay, this stuff's about minus 200 degrees. Okay, so it's incredibly cold. Now, earlier I did a bit of a Blue Peter. I shouldn't be taking those off, actually. I don't know what I'm doing. And I dropped something in here. I dropped a banana in here. And bananas are very good because they're squishy like us. Okay? So that doesn't sound too good. And then I can pour this out. You can see there. And it instantly becomes a gas again. Because it's so cold, the air warms it up. Now, can we see this okay? Now, this is what would happen to your body in space. Okay, it would become incredibly brittle. So, not only would you have the problem of a vacuum, it would also have the problem of freezing. So let's see what would happen as you tried to touch anything. And you wouldn't want that, okay? So, not only do those spacesuits keep people protected from the vacuum of space, they actually keep them protected from the cold. It's nice there, actually. Sorry, can we go back to the slides? Oh, where are we? And this is, can you see on the back? That's actually, most of it is basically warming them up to stop them being cold. And not a lot of that is oxygen. Now, obviously, this was such a massive achievement. Basically, America won the space race. And it's really sad because no one's been back to the moon. We were meant to go on to Mars, and everyone had all these amazing ideas of going on to other planets. And no one's been back, actually. Now, I should, but we are going to go back, okay? Now, does anyone out there know what this is? Well, it's actually, I should say it's a TIE fighter. But does anyone know what TIE stands for? There's usually one that's very nervous to admit it. There's a chap over there. No. Is there anything else someone does? Oh, you're a teacher. That's a twin ion engine. He does know. It's because someone who's been as lonely as me at night, haven't you? Googling stuff, yes. Stands for twin ion engine. Sorry, I shouldn't have said that. It says more about me. But anyway, basically, we are actually producing ion engines now, actually. What's quite amazing is this is actually, it was too dangerous for me to do it, believe it or not, but this is a spacecraft or a test spacecraft that runs on electricity. It needs about 50,000 volts to work. Okay, you can see there's a wire at the top, and you're just turning it down to make sure it floats nicely. I couldn't do this in here, it's way too dangerous. But that wire is just supplying electricity. And all this is running on is basically pure electricity, no other fuel. Okay? And what you've got there is a kind of negative wire at the top, and that's where you get electrons, and you've got a positive skirt at the bottom. Now, what do opposites do? Attract. So these electrons jump down. And as they go down, they move in that direction. Which way would we expect our craft from Isaac Newton earlier? Upwards. So actually, you can use these things. We can use ion engines now to kind of get to other planets. Now, why I'm really excited is that basically China landed a probe on the moon yesterday. And it wouldn't surprise me, within 10 to 15 years, they land human beings on the moon. I'm really excited about that. And why I'm also excited is because basically Europeans, the Americans, basically human beings are going to go back to the moon. But in about 30 years, I suspect, human beings will land on Mars. And it's actually, I'm going to be way too old for that. But what really excites me is it's one of you people in the audience now. One of you guys could be the first human being, the first man or woman to land on Mars. Okay, you'll be about the right age. That's what I get really excited about, actually. I could be talking to here the first human being on Mars. And I think that's really important, basically. As I say, believe it or not, I'm too old for this now. I was going to say, it's going to be one of you guys. So hopefully in the future, I'll be able to say, I'm sure I knew her or him when I'm seeing you on the TV, okay? That's really important. So basically, I think we've come to an end there. We've all survived it, just. And quite worryingly, in about the 45 minutes we've been doing that, you've learned about as much as me about rocket science. So thank you very much.